Last lesson we learned how we can draw a model by freehand just using the mouse. However, this is the slow and cumbersome way to build a Ventsim model. A far better way is to actually import a CAD file from a mine planning package or from AutoCAD and use this as the basis for creating a Ventsim file. To do this, we have to import a graphics file. In Ventsim, these graphics files are called reference graphics, and to do this we use the file import option and we select the type of graphics file that we wish to import. Ventsim can import DXF files, which is a common drawing exchange format between CAD programs. However, you can also import DWG AutoCAD files, MicroStation DGN files, and Datamine DM files. Once the import window opens up, just choose the layers you wish to import, and also it's a good practice to change the color to ensure that it's nice and easy to see in Ventsim. Sometimes the dark colors are a little bit hard to see, and therefore I normally change the colors to yellow or white so they're easy to see. Finally, make sure that the metric and imperial option is chosen according to your type of coordinate system, and click on import. This file here only has center lines, and center lines are by far the easiest way we can build Ventsim models. Center lines allow Ventsim to wrap a Ventsim airway around the center lines. Other types of graphics such as triangulations or wireframes don't allow this feature and are much more difficult to convert to Ventsim airways. What we wish to do is we wish to convert these center lines to Ventsim airways, so we have to choose a function called convert center lines. This option is available in the pencil toolbar button, the one that creates Ventsim airways, and you'll see that there's a sub option to the side called convert center line. Choose this option and either click on the individual center lines or draw a fence or box around the entire model. This will convert all center lines inside the box to Ventsim airways. Now let's have a closer look at these airways. We can see as we move closer that each of the white spheres represents a junction or join between two airways. Now with the AutoCAD file, because the file is very detailed, there tends to be a lot of joins in those airways and it can be difficult to see. First of all, let's change the color. Ventsim has a wide variety of different data types it can color, but because we have no airflow or pressure in this model yet, we're simply going to try to color the airways according to elevation. So under the favorites menu or the attributes menu, there's an option there called levels, and this will color the model according to the elevation of the airways that are drawn. Next, we're going to try to simplify the model so that it's easier to manage and to view the ventilation parameters. We can see on this model here, the imported DXF lines have created a large amount of detail, particularly around corners, where to create the smooth bends, many segments have been drawn. In a ventilation model, these segments are largely redundant and we can simplify the whole thing by reducing the number of joins. Ventsim has a tool called Filter to do this. It's available in the Tools menu, and with Filter we can do two things. We can simplify the model and remove a lot of the unnecessary detail, and we can also bind the airways together so that if they don't exactly join, Ventsim can physically move and join those ends together. Each of these parameters has different settings, but by default the initial settings are fine, and by choosing the All Tools option from the Starting tab, we can run both of these options at the same time. Click on the Start button and you'll see that the model is both simplified, in this case by 249 airways, and also bound together. In this case here, 56 joins were created where airways were not exactly joined together. We can see the bends now have much less detail, and therefore the number of numbers and junctions and arrows that are shown are also much simpler as well, and it's just easier to see the simulation and the results. The next step to creating a model is to create your surface connections. Ventsim needs to know which airways go to the surface so we can simulate whether air will travel in or out of the mine. If we don't do this, then Ventsim will simply assume that these airways are dead ends and no flow will occur. So in this case here, we've selected all 4 surface airways, edited the airways and clicked on the surface option. And Ventsim now knows these airways will travel to the surface. Finally, we need to create some flow, so let's choose the shaft on the right hand side here. We'll edit the shaft, click on the fan option, and we have a choice of either putting a flow or a pressure into the shaft. At this stage we don't know what type of fan, so we're going to choose a pressure of 2000 pascals, and that will induce a flow in this shaft that will draw air through the entire mine. We run the simulation with the white Simulate Airflow button, and we should now see that the simulation is working, although it does have a large number of warnings. A closer look at the model reveals that the arrows show the airflow moving in most parts of the mine. However, the warnings, which are represented by yellow men at work signs, indicate that for some of those areas there are dead ends or no connections, and as a result those connections are shown as warnings. Ventsim simulations will treat these warnings as dead ends and no flow will occur. However, in some cases you may wish to check those dead ends to ensure that a connection was not actually desired or required. In this case here, these dead ends represent simply elements of the mine design where there is no connection, and as a result we can confidently in this case select all of these exit warnings by using the select button on the warning box, clicking the edit option, and you can see the edit option will choose 40 airways totaling 734 meters in length. And going to the first page of the edit box, there is an option there called Close End. This will define these headings as dead ends to Ventsim, and once Ventsim knows that, it will no longer show those as warnings. If we run the simulation again with the white Simulate button, we should now see that the simulation is successful, as shown by the green message at the bottom of the screen, and we'll see that the numbers and the arrows show the various directions and speeds of the airflows. We can also change the graphic size and the text size to make it easier to see. Finally, when we change these airways, these center lines to airways, Ventsim doesn't define a specific size. That's because the DXF file does not contain the information about the size of an airway. So in this case here, we're manually editing and changing the size of the airway, in this case the ramp from the surface to 6 meters wide by 6 meters high with an arched profile. And we need to do this for the entire model to ensure that the sizes of the airways in the model match the requirements of the mine design. Once we're happy with this, we can then finalize our model and get the results of the simulation. And the results should be indicative of what you would expect for this mine design to produce once it was mined and was in production. Now obviously there's more to a ventilation design than just pushing air through tunnels. We need to control the air and direct it to where it needs to go. And in the next tutorial we'll learn how we can use some of the features in Ventsim to control airflow, both in terms of speed and direction, and as well as looking at what types of fans we can use to produce the flows and pressures we require.